Hello, everyone. My name is Israel Ago Jr., and today I will be talking about electronics and electricity. So, some basic things we discussed. When a charge wants to move through the path of least resistance to its greatest opposite, it also needs to be either the opposite charge or it needs to be grounded, in which the conductor with the metal studs, of course, has to be encased into that device. But electrical devices, they use the flow of electricity to make light, heat, magnetism, motion, and etc. Just like, for example, the light switch that I use to turn on my fan, or the electromagnets or motors I have inside my laptop or around me. That also includes speaker cones, dynamic microphones, such as the Yeti microphones, or guitar pickups. Now, you might think of electronics as shaping how electrons behave rather than purely letting an electric charge simply run through a circuit and do its thing. But it also has to do with light, heat, and magnetism. And there are a few things in which using semiconductors can shape the flow of electricity in more advanced ways, such as when a lamp with a motion sensor is activated, or when an analog synthesizer shapes the incoming power source into waveforms. And digital also works too, because you're thinking of digits, you're using numbers, words, and with semiconductors, you conduct the electricity, but you have to shape for the distinct purpose. And there's many different forms of it. There's transistors, there's amplifiers, there's Moore's law, which is known to describe how technology advances along an exponential curve. And then there's capacitors, there's diodes, there's transducers, resistance, voltage, and the list goes on. But if you want to compare the two, if you want to compare electricity with electronics, you have to know that electrical devices can convert electrical energy into other forms of energy, for example, heat, light, and sound. Electronic devices, however, they control the flow of electrons in order to perform a task. Now, if we go back to what we talked about, we know that if we want to calculate power, we have to find out, okay, it's measured in watts, and it's the rate in which energy is generated or consumed. And we ask ourselves, okay, is the gear going to blow up? Is the circuit going to break? Is the laptop going to go haywire? Who knows? And another thing to keep note is that all of these electronics and electrical devices, they're always used to cooperate with each other. Like, all of these things go together in many ways. Of course, there's differences, but a great example could be that, so you know how the fan, right? The fan is supposed to keep us cool because it's either hot outside, or if we want to have the air conditioning on because it's cold and we want the heat on. So fans and transformers and motors, along with generators, are all examples of electrical devices, but electronic devices can be transistors, thyristors, microcontrollers, and laptops. One thing to point out, though, is that, again, electricity flows through electrons, through conductors, and electronics are, like, you can say, the conductor of what there is of electricity. But I'll leave it at that, and I hope you have an amazing day. Let me know if there's any errors in the comments. So thank you.